Alright, this video is over properties of logarithms. What's up, math people? Alright, so this thing right here, the key behind it is just knowing how to use the tool. We're just going to jump straight into the properties. The first property we're going to focus on is when we have log as an actual exponent. Alright, so when you raise something to a power that has a log and the bases are the exact same, the solution is just the expression of that log. Property number 2, let's say you have a log of base a and the expression is a raised to some exponent. The solution is just the exponent. And let's say we have property number 3. This is when it starts picking up a little bit. When you have a product inside of a log base a, that product can be expanded as a sum as long as you keep the bases the same. Alright, whenever you have a quotient inside of a log, that quotient can be expanded using subtraction. Alright. Now, last little property is just taking that power as a factor. Bring the power r out front as a factor. And alright. Now, time for the easy stuff. Examples. Alright, so the first example, we have log base pi of pi raised to the third power. Notice we have a log and the base and the expression are the exact same. If we look at property number 2, we'll see that the solution is just the exponent. Easy enough. Alright, another example where we have 5 raised to the log base 5 of square root 3. Now look at that example. The log is an actual exponent. The base of the log and the base of itself is the exact same. If you look up at property number 1, you'll see that the solution is just the expression of the log. I told you, it's just knowing how to use your tools, man. And finally, we have log base e of 0.35 t. Alright, this one might look tricky, but if you recall from the previous lesson about logarithmic functions, when we first introduced logs, we know that the base of natural log is e. So essentially we have the base is the exact same thing as the expression. So if you look at property number 2, once again, the solution is your exponent. Alright, let's amp this thing up a little bit. Alright, let's say we have log base 4 of 32 minus log base 4 of 8. Alright, well, let's just work this thing in reverse. Alright, what I want you to notice is that the bases on both of these are 4, and these two expressions are separated by a subtraction sign. So if we work in reverse, we can combine that into one expression with one base using division, and that will give us log base 4 raised to the 4. Now, what is the exponent on 4? If you said 1, thank you. Now I want you to move. We just use, I'm going to write the properties in green. First, we use property number 4. We use property number 4 here. And now we're about to use property number 2 to get the final answer. And the final answer is 1. Because the base and the expression are the same, the solution is the exponent. Alright. Let's move this guy up right quick. Get us another example. Let's say we have log base 15 of 3 plus log base 15 of 5. Notice that the bases are the same, so we're going to use property number 3 to combine those. Because they're separated by addition, we're going to combine those using multiplication. 3 times 5 equals log base 15 raised to the 15. And again, please tell me the exponent on 15. That's 1. Solution's 1. At times you might need to expand a logarithm. If you need to expand a logarithm, we need to know how to expand that guy, right? So let's see here. Let's do an example where we're actually expanding the logarithm. Alright, so let's say, alright, expand the logarithm. Alright, so we have log base 6 of 36x, and all we want to do is expand this log. Alright, so inside of that parenthesis we have multiplication. We know from the property number 3 that we can expand multiplication. We can expand multiplication using addition. Give me my, thank you. So using addition, we have log base 6 of 36 plus log base 6 of x, and we'll simplify the log base 6 of 36. Thirty-six is the same thing as saying 6 squared plus log base 6 x. So this solution would be 2 plus log base 6 of x. Notice I use one of the properties from up top, property number 2, to simplify log base 6 of 6 squared. Alright. Now let's Look at this guy. Real quick example. I want you to tell me the simplification step is just to write this from a power to a factor. That's all I want you to do. So first thing I want you to do is identify what the power is that will become a factor. If you said 4, you in the game, you've been paying attention. So we have 4 times log base 3z. And that's done. That's simplified. That is as far as it can go. Okay. And we'll do a couple more examples and then we'll get up out of here. Alright, so let's say we have natural log of x over e to the x. Okay, natural log. Alright, so we're going to expand this. We have division inside the parentheses, so if you have division inside the parenthesis, what will you use to expand it? Addition or subtraction? Oh yeah, subtraction. So we have natural log of x minus natural log of e to the x. Again, what is the base of natural log? If you said e, you are killing it. So we now have in this second term, base of natural log is e, and the base of the expression is e. So that solution component is just x. Alright, so we've went through expanding the logarithm. Now how about we go through and just write it as a single log. Write as a single log. Alright, so we're just basically working in reverse. Alright, first example, we have 5 log base 7 of u plus 2 log base 7 of v. Alright, so what I always recommend, alright, if you have factors out front, that's the first thing you want to do whenever you write this thing as a single log. Turn those factors into powers. So we have a factor of 5 on the first one and a factor of 2 on the second one. So I'm going to turn those factors into powers. So that gives me log base 7 of u raised to the 5th power plus log base 7 of v raised to the 2nd power. Alright, after you've turned those factors into powers, alright, you have the same base separated by addition. If you separate it by addition, you're going to combine it using multiplication. That's what I'm talking about. Y'all are geniuses, man. And that is your final answer. Alright, let's get another example here. Let's amp it up a little taste. Let's say you have log base 4 of x squared minus 49 minus 4 log base 4 of x plus 7. Alright, looking at this example, do we have any powers that need factors that need to be written as powers? Not in the first term, but in the second term we have that 4 right there. So we have log base 4 of x squared minus 49 minus log base 4 of x plus 7, the entire expression raised to the 4th power, Alright, those two terms are separated using subtraction, so we'll combine them with a single log using division. We have x squared minus 49 over x plus 7 to the fourth. That is equal to, alright, we got some simplification that we need to do. X squared minus 49 is a difference of squares. Alright, so we have x minus 7 times x plus 7. That's what x squared minus 49 factor to be. And this is all over x plus 7 to the fourth power. Alright. Now, we're going to do a little simplification, and that leaves us with log. So, x minus 7, the x plus 7 and the numerator reduces the 1 in the denominator by 1 unit. To give us x minus 7 over x plus 7 to the third power. Alright team, your final thing that I want you to take away from this section is this last formula is the change of base formula. Change of base. And this will help you out a lot once you move forward into calculus or whatnot. No, don't talk calculus. Let me get through college algebra and I'm done. Alright, the change of base formula is you take the log of the expression, the common log of the expression over the common log of the base. Or you can take the natural log of the expression over the natural log of the base. You get the same answer. Alright. Alright, here's your final example of this section. Using the change of base formula. Give the exact solution. You have log base 5 of 89. The exact solution using the change of base formula. I'm going to say the natural log of the expression. Oh, the expression is 89 over the natural log of 5 over the natural log of the base. Done. Alright team, that is the closing of that section. I hope this video helps, and we'll be in contact soon.